Welcome to GCE O-Level series. This is Unit 8, Writing Chemical Equations. Most of the time, people think that anything which is chemical in nature is bad for us, and anything which is natural is good. Yet, nature is chemical. We have to understand this thing. Have you ever thought that if we'll exclude chemistry from our life, so probably the life would be totally impossible? Why is it so? Because if we look around us, so there are so many chemical reactions happening in order to maintain life on Earth, such as photosynthesis. Photosynthesis is a process by which the plants can produce their food by various chemical reactions. Combustion is a burning process by which fuel burns and produces a lot of energy, which is domestically used for cooking. Respiration is another example of chemical process or chemical reactions, without which life doesn't exist. Melting process, iron, rusting of iron, and much more. If we start counting them, so we would not be able to do so. So let's dive into the details of chemical process and chemical reactions. Before commencing chemical reactions, you should understand what is a chemical process. It is basically a process of conversion of reactants into product. This procedure yields the products which are having different properties and which are more stable. Let's take an example of methane. Methane is a natural gas which is used as a fuel in our gas stoves. So the formula of methane is CH4. When it will be oxidized, it will be producing carbon dioxide along with water. So this is the equation of the combustion of methane. So it is a chemical process. There is another example in order to understand chemical process is the photosynthesis. In the presence of sunlight, plants easily convert carbon dioxide into glucose by a process which is called as photosynthesis. So carbon dioxide will react with water and it will produce glucose and oxygen. So these are the equations which are representing the chemical process. A chemical equation is basically the representation of the chemical process. And the chemical equation is always having two parts. Let's take an example. Let's suppose hydrogen is reacting with oxygen in order to produce water. So here you can see this is the representation of formation of water molecule. So, and this is its complete chemical equation. In this equation is having two parts. This part of the equation is called as reactants, whereas this part is called as product. Always remember, all those atoms which are reacting to produce a new product will be written on the left hand side, whereas the newly formed product will be written at the right hand side. And there will be one arrow which will be representing that either it's a forward reaction or it is a backward reaction or it is either a reversible reaction. If it's a forward reaction, so this arrow will be represented. If it's a backward reaction, it will be having this. If it's a reversible, so it will be having this kind of representation of arrow. A chemical equation shows what happens in a chemical reaction. It tells us which reactants and which products are involved in the reaction. The relative amount of reactants and products will be also mentioned in the chemical equation. The physical states of the reactants and the products are also mentioned in the chemical equation. Again, let's take the example of methane. Here you can see we are oxidizing it and we are getting carbon dioxide plus water molecule. So as I told you that a chemical equation will tell us that which reactants and which products are involved. So with the help of this equation, you can see that these are the two reactants which are involved in the chemical procedure, and these are the two products which are formed after the chemical reaction of these two reactants. Second thing was, which I told you, that it will also tell us that which amount, relative amount of reactants and product is present in the chemical process. So it will also tell us the relative amount by the stoichiometric calculations. And the physical states of reactants and products will also be known by the chemical equation. Look at this. This methane is present in the gaseous state. So there is a small g over here, which is representing the gaseous state of it. This oxygen is again in the gaseous state, so here is a small g which is representing its state. Carbon dioxide which will be obtained after the reaction will be in the gaseous state, so small g, and water will also be obtained as water vapors in the gaseous state, so small g is represented. Over here it's written. Now how can we balance chemical equations? In order to balance the chemical equations, there are certain very important rules for that. A balanced chemical equation, always remember, must contain an equal number of atoms of each element on the both sides of equation. For example, we are having hydrogen in the gaseous state reacting with oxygen, which is also in the gaseous state, and we will get water molecule which is in the liquid state. So here, look at this. We are having 4 hydrogens. 2 to the 4, we are having 2 oxygens, and on the other end of the equation we are again having 2 to the 4 hydrogens. With this 2 will be with this oxygen as well, so we are having 2 oxygens. So number of hydrogen, look at the both sides of the equation, is 4 and number of oxygen is 2, so it is equal. So always remember, a balanced chemical equation must contain an equal number of atoms on the both sides of an equation. And it is very, very important to balance the chemical equation. Now, what are the steps involved in balancing a chemical equation? There are certain steps which you have to follow in order to balance the chemical equation. Step number 1 is to write down the chemical formula of the reactants and the products. It's very, very important to write the accurate formulas of reactants and products to get the chemical equation. The next is to check the number of atoms on both sides of the equation. You have to count it and you have to see that both of them are correct or both of them are equal or not. Next is, the third one is to balance the chemical equation. You have to write down the accurate symbol. You have to balance it along with the accurate number of the atoms and put exponents if it's required to balance the number of atoms. So you have to put exponents in order to balance it. And the last one is to state the symbols which will indicate the physical states of each reactant and each product which are involved in the chemical equation. We will just see that how this will work step by step, each step. Let's suppose hydrogen is reacting with oxygen to produce water. As per the first step, we have written the accurate chemical formulas. Look at this. This is the chemical symbol of hydrogen or chemical formula of diatomic molecule of hydrogen. This is the accurate one of oxygen and this is the accurate formula of water. As per the steps, the second one is to check out the number of the elements on the both sides of the equation. See, we are having 2 hydrogens over here, we are having 2 oxygens over here, we are having 2 hydrogens but 1 oxygen. Step number 3 is to put exponents and multiply that exponent in order to get the accurate or exact number or equal number of atoms on both sides. So what we are going to do, as we are having 2 oxygens this side of the equation, in the product we are having 1 oxygen, so we will put our exponent 2 over here. And this is how we are going to get 2 oxygens over here. But the thing is that now we will get 4 hydrogens. This exponent will be multiplied by the subscript of hydrogen. So we will get 4 hydrogens. So what are we going to do? We have to now balance the number of hydrogens on the other end of the equation as well. So we will put exponent 2 over here. So now 2 to the 4, we will get 4 hydrogens. This is how the number of atoms on both sides of the chemical equation is now balanced. The last and the fourth step is to write down the symbols to indicate the physical states of reactants and products. So for that we have to write down the symbols. Let me write the symbols for this equation. So here you can see this hydrogen will be taken in the gaseous state, this oxygen will also be taken in the gaseous state, but the product will be found in the liquid state. So that's why we have to put a small l over there. Whereas in case of hydrogen and oxygen, we have to put small g as the symbols in order to indicate their physical state. If something aqueous will be used in the reaction, so we are going to use AQ at the as a subscript with that element which is taking part in the reaction. So this is the checkpoint. Now in this checkpoint it is asked that sodium reacts with chlorine gas to yield sodium chloride. Write a balanced chemical equation for the reaction of sodium and chlorine. First step is to understand the task. So this task is formation of sodium chloride. So the sodium metal is reacting with chlorine gas. Here we will be having sodium. The symbol of sodium is Na. It is reacting with chlorine gas. Chlorine will also be always be taken as diatomic molecule, and the yield will be sodium chloride, NaCl. So the first step was to write down the symbols. So we have written the symbols accurately. Second is to check out the number on the both sides. Let's check it out that number of atoms are equal or they are unequal. Sodium 1, chlorine 2. Here sodium 1, chlorine 1. So it's unequal. We have to, the third step is to put exponents in order to balance the number of atoms on both sides of equation. So what are we going to do? We have to put exponent 2 over here. As we are going to put exponent 2 over here, so it will be multiplied with both of the elements which are present inside the compound. So as a result, we will be having 2 oxygens. And we will be having 2 chlorine. So number of chlorine is now equal on both sides, but number of oxygen is now not equal. So what are we going to do? We have to put exponent 2 over here with sodium as well. So as a result, we will get 2 sodium. This is how we are going to balance it. Now 3 steps have been followed. Come towards the fourth step. The fourth step is to mention the states. Sodium will react as a, it is found as a metal, so it will be used as a solid. Chlorine will be used as a gas. So as a result, we will get sodium chloride, which is also solid. So this is how you're going to follow these four steps in order to get the chemical equations. Thank you so very much for watching the video. If you like the video, give a very big thumbs up and comment below in order to clarify your query.